Without graphing, determine whether the equation has the graph that is symmetric with respect to the x-axis, y-axis, the origin, or none of these. So we're going to begin with determining whether it's symmetric with respect to the x-axis by removing the y and replacing it with negative y. Recall, an even number of negatives is going to equal a positive. So you're going to have the same equation you started with, so we can conclude that the graph is symmetric with respect to the x-axis. Let's move on to determine whether the same equation is symmetric with respect to y. So we're going to remove x and replace it with its opposite. Once we do that, it's going to look like so. And recall, an even number of negatives will always equal a positive. So as you can see, we end up with the same thing that we started with. So we can conclude that this graph is also symmetric with respect to the y-axis. And now lastly, we want to determine whether this equation is symmetric with respect to the origin. So recall, to find that out, we have to remove x and y and replace them with their opposites. So once we plug in negative x and negative y, notice again, an even number of negatives will always equal a positive. The result is the same as what we started, so therefore we have to conclude that this particular graph is symmetric with respect to all three. It's symmetric with respect to the x-axis, the y-axis, and the origin. Now, if you look at this equation, it's actually an equation of a circle with a center at 0, 0. And that is why it has symmetry there. It's centered at the point of origin at the center. You can fold it several ways, and it's always going to have that symmetry. Now, that's not for every circle. That's only for circles that have the center at the origin.